Section 8.1 Basics of Hypothesis Testing. Back in Chapter 7, we learned how to estimate the value of parameters. So parameters can be population mean, population proportion. For example, we construct the confidence interval for the mean. So if we say the confidence interval is from 40 to 45, means that the mean is any number from 40 to 45. Or we can construct the confidence interval for the proportion, say 0.21 to 0.35. That means my proportion is a number within these two limits. In this chapter, instead of estimating the values, we are trying to answer the questions. Is mu equals to 80? Or is p greater than 0.17? Or is mu less than 16? This is what we're trying to answer in Chapter 8. Yes, it's equal to 80, or no, it's not greater than 0.17. And we have to use the hypothesis testing in order to answer these questions. In statistics, a hypothesis is a claim or statement about the property of a population. Property of a population can be mu, p, or sigma. Population mean, population proportion, population standard deviation. So hypothesis is just a statement about these values. A hypothesis test, or can also be called the test of significance, is a procedure for testing a claim about a property of a population. Property of a population can be mu, p, or sigma. For example, if I want to answer the question, is mu equal to 16? This is a statement about the population mean. To answer this question, I have to do the hypothesis test. The null hypothesis, denoted by HO, is a statement that the value of population parameter is equal to some claimed value. For example, HO can be mu equals 16, or HO can also be p equals to 0.75. HO is always the statement about your population parameter, and HO always contains the equal sign. The alternative hypothesis, denoted by H1 or HA, is a statement that the parameter has a value that somehow differs from the null hypothesis. For example, HA can be mu is not equals to 16, or HA can be p is greater than 0.75, or HA can also be p less than 0.12. HA is a statement about the population parameter, and HA only contains the inequality. So in your HA, you will only contain either the not equal to, or greater than, or less than. Example 1. The mean pulse rate in beats per minute of adult males is equal to 69.2. For a random sample of 169 adult males, the mean pulse rate is 69.8 and the standard deviation is 11.1. Identifying the null and the alternative hypothesis. So in this question, they want me to identify the HO and HA. In order to identify HO and HA, we need to follow these three steps. Step 1. Express the original claim in the symbolic form. So first thing we're going to do is read the whole problem to see which one is the original claim. The mean birth rate of adult males is equal to 69.2. For a random sample of 169 adults, the mean birth rate is 69.8 and standard deviation is 11.2. How do I know which one is the original? First, from here, I know that I have a sample of 169. And from this 169 people, I measure their birth rate and that mean is 69.8. So this 69.8 is only my sample mean because this is the mean of 169 adults. This is my X bar right here. And 11.1 is my sample standard deviation is S. So these are the statistics, not the parameter. Remember, when you are performing the hypothesis testing, you are dealing with the parameter, not the statistic. In my original claim, say mean equals 69.2. I use mu instead of X bar here because when we are doing the hypothesis test, we are testing on the parameter, which is population mean or population proportion. That is the first step. Step 2. If the original claim is false, then what happened? So my original claim is mu equals to 69.2. What if this is false? Well, that means when mu is not 69.2, right? And the last step is when we are trying to identify HO and HA. So from these two right here, the statement that you have from step 1 and step 2, you pick the one without the equal sign for your HA. So HA only contains the statement with the inequality, which is not equal to in this case. And HO always contain equal sign. This is my HO and HA. Example 2. A majority of adults would erase all of their personal information online if they could. A software firm survey of 544 randomly selected adults showed that 63% of them would erase all of their personal information online if they could. Identify the null and alternative hypothesis. First, a software firm surveyed 544 random adults. This is my N, and 63% is my P hat, because this is my sample proportion. I am working on a hypothesis test. I'm not using the sample statistic. I am going to use the population parameter. So it would be P. From here, it's a majority of them. So majority of them is going to be a big portion of it. Now, I don't know how big that is. Could it be 60%? Could it be 70% or 80%? All they gave me was the majority. So to be on the safer side, I say the majority would be greater than 50%. P is greater than 50% is my original claim. Second step, if the original claim is false, then what? So the original claim is P is greater than 0.5. What if this is false? That is when your P is less than 0.5 or equal to. From here, I am going to identify my HO and HA. From the two statements that you have from the first two steps, you are going to pick the one with no equal sign for your HA. This one has equal sign, it could not be in your HA. This one has no equal sign, this is going to be a statement on your HA. P is greater than 0.5. And on your HO is P equal to 0.5. Now, if you use P is less than or equal to 0.5 on HO, that could also be right as well. Example 3. Fewer than 95% of adults have a cell phone. In the Marist poll of 1,128 adults, 87% say that they have a cell phone. Identify the null and alternative hypothesis. Step 1. Express the original claim in the symbolic form. So my original claim say fewer than 95% of adults have a cell phone. This is about proportion, and in this original claim say that fewer than 90% have a cell phone. So P is less than 0.95. If P is less than 0.95 is false, then P should be greater than or equal to 0.95. From the two statements I have from the first two steps, the one doesn't contain equal sign is going to be my HA. And my HO is going to be P equal to 0.95. Again, if you use P is greater than or equal to 0.95 for HO, that could also be correct. The significance level alpha for a hypothesis test is the probability value used as the cutoff, determining when the sample evidence constitutes significant evidence against the null hypothesis. By its nature, the significance level alpha is the probability of mistakenly rejecting the null hypothesis when it is true. Significance level alpha equals to probability of rejecting HO when HO is true. The most commonly used significance levels are 0.01, 0.05, and 0.010. If significance level is not given, then we always use 0.05. The cuticle region, or can also be called the rejection region, is the area corresponding to all values of the test statistic that cause us to reject the null hypothesis. Let's use alpha equals 0.05. When working on a hypothesis test, you are going to encounter one of these three tests. We have two-tail test, left-tail test, and right-tail test. Two-tail test is when you have your alpha on the two-tail on both sides. Left-tail is when your alpha is on the left side, and right-tail is when the alpha is on the right side. Now, how do you know when it's right-tail, when it's left-tail, and when it's two-tail? You look at your HA. If your HA contains not equal to, then you are going to have two-tail test. If your HA contains less than, then you are going to have the left-tail test. And if HA contains greater than, you are going to have the right-tail test. For example, if alpha equals 0.05, in a left-tail test, this piece is 0.05. In a right-tail test, this P is 0.05. But in the two-tail test, your alpha is split into half. This is half of alpha, and this is also half of alpha. So that is 0.025. And these regions where alpha are, they are called the rejection region or cuticle region. The test statistic is a value used in making a decision about the null hypothesis. It is found by converting the sample statistics, such as p-hat, x-bar, or s, to a score, such as z, t, or chi-square, with the assumption that the null hypothesis is true. In a hypothesis test, the p-value is the probability of getting a value of the test statistic that is at least as extreme as the test statistic obtained from the sample data, assuming that the null hypothesis is true. We are going to use technology in order to find the p-value and the test statistics. In here we have StatDisk, Minitab, Calculator, and StatCrunch. We are going to use StatCrunch for this calculation, and Z-stat is your test statistic, and p-value is your p-value. Here is the procedure for hypothesis test. The first 3 steps are the steps that we use to identify HO and HA. The 4th step is when we determine our alpha. Alpha is mostly given to you in a problem. If it's not given, we are going to use 0.05. Step 5 is when we use StatCrunch to find the test statistic and the p-value. There are 2 different methods that we can use in order to make a decision. We are going to use the p-values method. With the p-value method, we are comparing the p-value with alpha. If p-value is less than or equal to alpha, we reject HO. If p-value is greater than alpha, we do not reject HO. And the last step is when we restate our decision in non-technical terms. I also created a chart to help you with your conclusion. If your original claim does not include the equality, then there are 2 situations. If you reject HO, then your conclusion should be there is sufficient evidence to support the claim that, and then you're going to insert your original claim in. If the original claim does not contain the equality and you fail to reject HO, then your conclusion should be there is not sufficient evidence to support the claim that, and then you're going to insert your original claim in. If your original claim includes the equality, then there will be 2 different situations as well. If you reject HO, then your conclusion should be there is sufficient evidence to warrant the rejection of the claim that, insert your original claim in. If the original claim includes the equality and you fail to reject HO, then your conclusion should be there is not sufficient evidence to warrant the rejection of the claim that, insert your original claim in here. Example 4. A majority of adults would erase all of their personal information online if they could. The hypothesis test results in a p-value of 0.3257. Use the significance level of alpha equals 0.05. A. State the conclusion about the null hypothesis. In order to do this, I need to have my HO and HA. I found HO and HA for this problem in example 2. I am going to just rewrite it here. HO says proportion equals 0.5. HA says proportion is greater than 0.5. State the conclusion, or could also be make your decision. Would you reject HO or would you not reject HO? In order to make your decision, all you do is comparing your p-value and your alpha. P-value is 0.3257, which is greater than alpha. you do not reject your HO. B. Without using technical terms or symbols, state the final conclusion that addresses the original claim. Original claims say a majority of adults would erase all of their personal information online. So original claims say that P is greater than 0.5. So I want to address that. My HO is P equals to 0.5. My HA say P is greater than 0.5. I failed to reject HO. What does that mean? It means that I don't think that P is greater than 0.5 because I failed to reject this. You can go back to the chart that I made you earlier in order to help you with the conclusion. First of all, your original claim does not contain the equality. It contains the greater than, and you failed to reject HO. Original claim do not include the equality, and you fail to reject HO. There is not sufficient evidence to support the claim that. Now I am going to insert my original claim in. A majority of adults would erase all of their personal information online if they could. Example 5. The mean pulse rate of adult males is equal to 69.2. The hypothesis test results in a p-value of 0.0095. Use a significance level of alpha equals to 0.05. A. State the conclusion about the null hypothesis. In order to do this, I first need to state my HO and HA. HO and HA for this problem was found in example 1. So I am going to just restate that. In order to make my decision, all I do is just look at my p-value and my alpha. P-value is 0.0095 and alpha is 0.05. So p-value is less than alpha. That means I will reject my HO. B. Without using any technical terms, state the final conclusion. So first, my original claim say the mean equals to 69.2. So the original claim contains equal sign, and I reject HO. Original claim includes equality, and you reject HO. The conclusion would be, there is sufficient evidence to warrant the rejection of the claim that. Now I am going to insert my original claim. The mean pulse rate of adult males is equal to 69.2. When doing the hypothesis test, there are chances that we are making errors. And if we ever make an error, there would be one of these two types. For type 1 error, the mistake of rejecting the null hypothesis when it is actually true. So alpha is the probability of type 1 error, which is probability of rejecting HO when HO is true. Type 2 error, the mistake of failing to reject the null hypothesis when it is actually false. Beta is the probability of type 2 error, which is the probability of failing to reject HO when HO is actually false. When doing the hypothesis test, you will have two different statements, HO and HA. If you reject HO, that means you don't think HO is correct. You believe that HA is correct. So if HA is correct, you make the correct decision. If HO is correct and you reject the HO, you make the type 1 error. So for type 1 error, you reject HO, but it turned out to be HO is true, you make the type 1 error. If HA is true, then you make the correct decision. If you fail to reject HO, that means you think HO is correct. You think HA is not correct. So if HO is correct, you make the correct decision. If HO is not correct, then you make a type 2 error. So when you fail to reject HO, if HO is correct, you make the correct decision. If HO is not correct, then you make a type 2 error. Example 6. The percentage of adults who retire at the age of 65 is greater than 62%. A. Identify the type 1 error and identify the type 2 error. In order to identify type 1 and type 2 error, I need to have my HO and HA first. In order to do that, I need my original claim. My original claim say that the percentage is greater than 62%. Step 2. If my original claim is false, if P is greater than 62% is false, that is when P is less than or equal to 62%. And the last step is identifying my HO and HA. So between the two statements that I have from the first two steps, I will pick the one without the equal sign for my HA. And my HO will be P equals to 0.62. If you use P is less than or equal to 0.62 for HO, you are still correct. You have two statements, P equals 0.62 and P is greater than 0.62. And only one of those is correct. It cannot be both correct at the same time. A. Identify the type 1 error. Type 1 error is when you reject HO, but in fact, HO is correct. That means you don't think that P is equal to 0.62, but it's actually equal to 0.62. B. Identifying the type 2 error. Type 2 error is when you fail to reject HO. That means you believe that P is equal to 62%, but when in fact it's not equal to 62%.